Hello and welcome my dear students to yet another session of 15-day sprint program for IIT JEE Mains. In this session we'll be discussing chemical bonding, which is one of the vital topics for inorganic chemistry as well as organic chemistry. Why chemical bonding? Because chemical bonding से लगातार हर साल questions आ रहे हैं. And in this session we have tried to ace some important concepts of chemical bonding. These concepts you might have read earlier, but it would be good that if you sit with a pen and paper and do a proper revision as and when it is required, and do a proper revision along with me so that your concepts get revised. There are so many topics that need to be covered within chemical bonding, but we will be focusing mostly on those areas जहाँ से question generally पूछे जाते हैं. Okay, so without further wastage of time, let's dig into the question. I'm Saurav. Those of you who don't know me, I'm Saurav. I have done my master from NIT Rourkela, and this is the session that I'm gonna take. So let's go on to the next slide and understand what is the distribution of inorganic chemistry for the whole of chemistry syllabus. So inorganic chemistry, as you can see, I've seen this chart earlier as well when Pahul sir and Abhilash sir was taking the sessions. So inorganic chemistry accounts for about the same weightage as organic and physical. आप inorganic को exclude नहीं कर सकते हैं. It's like a tripod. Okay, so एक leg completely ignore नहीं कर सकते हो. However, you can pick and choose those topics which are most frequently utilized by the JEE board to ask questions. So वो सारे topics को हमें लेना है and उन्हीं topics को हमें समझना है फिलहाल in 15 days में. Okay, let's try and look at the topic wise distribution of frequency of questions. So in 2018 till 2014, so what we can see is that we have analyzed this 5-year pattern, and we can see that from chemical bonding, you can see that there are 11 questions that were asked in 2018, keeping offline and online together. Similarly, periodic properties से एक ही question आया यार, तो periodic properties अगर आप थोड़ा miss भी करते हैं और if you average at it, you'll be able to sail through. But coordination and salt analysis, इससे questions आए हैं. Similarly, what you can see over here is that group study से भी questions आते रहते हैं, but not very frequently. But see, 2016 there were 19 questions in offline as well as an online examination which had come from group study. Now in metallurgy भी आप not that very important, but group, chemical bonding, coordination, salt, ये सारे important है. अगर आप इनसे दो questions भी solve करते हो, अगर examination में you solve about 2 questions from chemical bonding, a question from coordination, a question from salt analysis, and a question of periodic properties, you will be able to sail through the inorganic chemistry portion of the JEE Mains examination. Okay, so let's move ahead and take the first question for today. Okay, so the first question is, in ClF3 molecule, the structure and hybridization is. In ClF3 molecule, the structure and hybridization, ये सारे लोगों को मालूम है. ये बहुत कॉमन क्वेश्चन है और बहुत लोगों ने इसको बहुत तरीके से इसको सॉल्व करने का मेथड सीखा है. हम लोग बहुत ईजी तरीका सीखेंगे. एंड द मेथड इज दैट ClF3, I can write ClF3 like this, ClF, and we can write 2 lone pairs. Now, if somebody asks, or if somebody has a confusion, how did we get this? Then what we can say is chlorine. Okay, let me take a different color pen for this. Chlorine के valence shell में कितने electrons? 7. How many fluorine it is bonded with? 3. So each fluorine donates 1 electron. So कितने total electrons donate हुए? 3. Are any other electrons coming into picture? No. So 7 electrons in chlorine's valence shell, all of them are receiving 3 electrons from fluorine. So a total of how many pairs can we form? 5 electron pairs. इनको हम डिवाइड कर देते हैं बॉन्ड पेयर्स एंड लोन पेयर्स में. कितने बॉन्ड पेयर्स हो गए, कितने पेरिफेरल एटम्स हैं, 3, सो 3 बॉन्ड पेयर्स एंड 2 लोन पेयर्स. This number will give you the hybridization. How? The sum of the powers of S, P and D orbitals which are involved will be equal to this, or if is equal to this will be the hybridization. अगर ये number 4 आता है then sp3. If this number is 6 or 6 electron pairs, the hybridization will be sp3d. If it is 5, then it should be trigonal bipyramidal. Okay, now dsp3 and sp3d में confusion हो सकता है because d आपने लिया है, आपने पहले लगाया बाद में लगाया. What is that significance? dsp3 is when n-1th d orbital use होता है. This is generally observed in coordination compounds where 3d orbital is used and 4s is used. So 4s के लिए principal quantum number 4 है and 3d के लिए principal quantum number 3. So उसको हम लिख सकते हैं n-1th d orbital. But in this case we are utilizing 3s, 3p and 3d. So we are not utilizing n-1th. तो ये हो नहीं सकता है. sp3 तो नहीं होगा, sp2d नहीं होगा. The correct answer is B. Easy question, takes about 30 seconds to solve, even 15 seconds to solve. Okay, next. So let's take the next question. The next question is slightly tricky. ClF3 and PF2Cl3, the position of fluorine around the central atom is. Okay, now I'll take a moment to explain what is the concept behind this. Okay, so now if I write the hybridization of ClF3, I can write it as sp3d. If I write the hybridization of PF2Cl3, I can write it as sp3d as well. ये आप दोनों कैलकुलेट कर सकते हो. Now हम फ्लोरीन को कहाँ पे रखेंगे, इक्वेटोरियल पोजीशन पे कि एक्सियल पोजीशन में. So sp3d hybridization looks something like this. If I take an atom over here, okay, so these are the position of our peripheral atoms or lone pairs, और ये भाई साहब हमारे सेंट्रल एटम है. ये भाई साहब हमारे सेंट्रल एटम है. ठीक है. नाउ लेट्स लर्न अ सिंपल कंसेप्ट. दिस इज आवर s ऑर्बिटल एंड दिस इज आवर p ऑर्बिटल. बोल सकते हैं इसको. S and P कंबाइन करके 3 तरह के ऑर्बिटल्स बना सकते हैं, sp, sp2, sp3. Okay, let's look at first these 3 things. So if I am making, so s orbital is spherical and this is elongated. Okay, now हाइब्रिडाइजेशन का मतलब होता है केक बेक करना. अगर आपने केक में चॉकलेट ज़्यादा डाल दिया तो चॉकलेट का फ्लेवर ज़्यादा आएगा. अगर आपने उसमें वनीला ज़्यादा डाल दिया तो वनीला का फ्लेवर आएगा. अगर दोनों प्रेजेंट है इक्वली तो दोनों के ही फ्लेवर आपको इक्वली मिलेंगे. सो इसका मतलब अगर हमारे पास एक हाइब्रिड ऑर्बिटल है and in that hybrid orbital I have more of s character, so the hybrid orbital shape will resemble more like s, less like p. If it has more of p character, it will resemble more like p and less like s. Can I say that? It's very easy to understand, the cake baking example. So what we do is we look at what these hybrid orbitals will look like. I'll just take one lobe of it. So if I draw can we say that in this case it resembles more like p orbital, so it must be having more p character, so p character इसमें ज़्यादा रहेगा. and in this case it resembles less like p character, so over here p character will be less. Now if I take sp2, sp3 and sp, can I say that this will be similar to sp3, sp2, sp? Why? पहले वाले में 75% p कैरेक्टर है, लास्ट वाले में 50% p character है. So p character is slowly decreasing, s character is slowly increasing. So it starts resembling s orbital very closely. It starts resembling p orbital as we move upward. It starts resembling s orbital as we move downward. Can we say that? So I can give you a simple relation. A simple relation is when s character increases, sphericity increases, p character increases, longevity increases. अब स्फेरिकल हो जाएगा तो एटम्स भी नजदीक रहेंगे तो बॉन्ड्स भी स्ट्रांग बनेगा, एंड p कैरेक्टर अगर इंक्रीज होगा तो एटम्स भी दूर रहेंगे. हाइब्रिड ऑर्बिटल का लेंथ ज्यादा है, एटम्स भी दूर प्रेजेंट रहेंगे, बॉन्ड भी वीक बनेगा. सो इस चीज को याद रखते हुए लेट्स मूव ऑन टू सॉल्विंग दिस क्वेश्चन. ओके, लेट्स मूव ऑन टू सॉल्विंग दिस क्वेश्चन. सो हमेशा याद रखो कि सेंट्रल एटम इज लाइक अ होस्ट. सेंट्रल एटम एक इज अ होस्ट एंड इट इज वेलकमिंग गेस्ट्स. तो मेहमान आ रहे हैं तो मेहमानों को उसको खाना परोसना है. नाउ अ मेहमान कम्स, अ किड कम्स, किड्स को चॉकलेट देंगे. एंड इफ एन एल्डरली जेंटलमैन कम्स, उसको तो चॉकलेट दे नहीं सकते हैं क्योंकि भाई डायबिटीज हो जाएगी, कुछ हो जाएगा, ये सब हो जाएगा. सो इट विल मेक फ्यू चेंजेस, बट नेट क्या होगा कि वो सभी को सर्व कर देगा. सो सिमिलरली व्हाट क्लोरीन विल डू इज दैट if I look at, okay, let's look at this from a different perspective. So this is our trigonal bipyramidal geometry. Okay, let's make them black so that there be slightly some difference. Now the linear part, ये जो the linear part, look at the linear part and look at the triangular part. Doesn't the if you remove the linear part, doesn't the triangular part resemble a sp2 hybridized kind of a unit? Planar, trigonal, planar. So हम इसको बोल देते हैं sp2 and the linear part will be pd. इन सबको मिला के if you mix sp2 and pd, you will get sp3d. Okay, so sp3d can be broken down into sp2, which is the equatorial planar part, and the linear part will be pd. Now tell me something guys, in which region s character is more? In which region s character is more? जहां पे s ऑर्बिटल है वहां s character ज्यादा रहेगा, s character is more, and in this region s character is less. Okay, now what is a lone pair? Lone pair is like a badmash bachcha. Lone pair is like a badmash bachcha. Lone pairs को हम कोशिश करेंगे कि उसके नज़दीक रखने का जिस पेरेंट से वो संभलता है. घर में बदमाश बच्चे रहते हैं, एक पेरेंट्स आइदर मॉम से डरते हैं या फिर डैड से डरते हैं, तो जिनके आसपास वो शांत बैठे उसको हम वहाँ पे रख देंगे. सो टेल मी समथिंग, इफ आई प्लेस अ लोन पेयर क्लोज टू द न्यूक्लियस, विल इट बी बेटर और वर्स? बताइए. इफ आई प्लेस वेरी गुड. इफ आई प्लेस द लोन पेयर क्लोज टू द न्यूक्लियस, इट विल बी बेटर क्योंकि अट्रैक्शन उस पर रहेगा. इफ आई प्लेस लोन पेयर अवे फ्रॉम द न्यूक्लियस, दैट विल बी बैड क्योंकि अट्रैक्शन कम रहेगा. सो lone pair would be placed in a hybrid orbital विथ मोर एस कैरेक्टर, क्योंकि ये भाई साहब आराम से लोन पेयर को पकड़ के रखेंगे। और ये जो आपका फ्लोरीन एलिमेंट है, फ्लोरीन इज हाईली इलेक्ट्रोनेगेटिव, सो इलेक्ट्रोनेगेटिव एलिमेंट विल ट्राई टू पुल इलेक्ट्रॉन्स। कहाँ से वो इलेक्ट्रॉन्स आराम से खींच सकता है? व्हेन द orbital is elongated, because it will be easier, because pull on those electrons will be less. So if the pull on those electrons is less, fluorine can pull electrons easily. So I can write electronegative element binds to orbital with lower sorry S character. It's very easy to understand, very conceptual, very easy to understand. So P, अगर लोन पेयर को मुझे रखना होगा तो मैं कहाँ पे रखूंगा? I will place somewhere over here. यहाँ पे लोन पेयर को रख देते हैं, क्योंकि यहाँ पे S कैरेक्टर ज़्यादा है, in this region S कैरेक्टर is more. और इलेक्ट्रोनेगेटिव एटम को प्लेस करना होगा तो कहाँ रखेंगे? Electronegative atom will be placed over here. Let's apply this concept on this. Okay. So we have Cl, दो लोन पेयर को पहले रख देते हैं, बचा एक फ्लोरीन, और यहां पे फ्लोरीन आ गया। ओके, next PF2Cl3, two atoms of different electronegativity. The one which is more electronegative will try to take up, or will win the competition, will try to take up the axial position. And chlorine को हम यहाँ रखते हैं। Is this clear? So which of our options is correct? Equatorial in ClF3 as well as in PF2Cl3? No. Axial in ClF3 as well as in PF2Cl3? No. Equatorial as well as axial in CF3, correct? Axial, equatorial, and only axial in PF2Cl3, this is correct. Equatorial as well as axial in ClF3 and PF2Cl3 is wrong. इसके ऊपर और एक क्वेश्चन डाल सकता है, अगर आपने PF2Cl3 की जगह PCl3F2 ले लिया, सॉरी PF3Cl2 ले लिया, PF3Cl2, तो आप इसको ऐसे रखोगे। आपसे ये पूछ देंगे कि डाइपोल मोमेंट किसका ज्यादा है, यहां पे सारे मोमेंट्स कैंसिल हो जा रहे हैं, ऑल मोमेंट्स आर गेटिंग कैंसल्ड आउट, सो डाइपोल मोमेंट फॉर दिस विल बी इक्वल टू 0, बट डाइपोल मोमेंट फॉर दिस विल बी नॉन इक्वल टू 0। ओके, इस तरह के और दो तीन क्वेश्चन आप ले लो, PCF3 होल ट्वाइस CH3 होल थ्राइस, PCF3 होल थ्राइस CH3 होल ट्वाइस। Group electronegativity of CF3 will be more as compared to CH3, same rules चलेंगे। Is this clear? This is a very fun to concept, and since it took some time for me to explain this, I hope you have learned this. Try to reapply it on other molecules which show trigonal bipyramidal geometry. एक चीज बस याद रखना कि अगर पेंटागोनल बाइपिरामिडल ज्योमेट्री रहेगा तो उसमें लोन पेयर को आप एक्सियल पे रखोगे, क्योंकि अगर आपने उसको इक्वेटोरियल पे रखा तो बॉन्ड एंगल्स आर इन द इक्वेटोरियल रीजन इन पेंटागोनल बाइपिरामिडल ज्योमेट्री इज 72 डिग्रीज। सो हमें लोन पेयर को लार्जेस्ट एंगल पे रखने की कोशिश करनी चाहिए। ओके, दिस क्लियर? लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन। फाइन, इन CH2Cl2 exact application of that, in CH2Cl2 bond angles can be represented as alpha, beta and gamma. What is the relation between alpha, beta and gamma? Let's try and solve this question. Generally people presume that CH2Cl2 is like sp3 hybridized, so bond angle will be 109 degree 28 minutes. They are not wrong in this, but overall it is 109 degree 28 minutes, but this 109 degree 28 minutes would be there for CCl4. or where all the atoms are alike, or CH4. But in CH2Cl2 the atoms are non-alike. So we cannot say that alpha, beta and gamma will be equal. We cannot say that alpha, beta and gamma will be equal. So what is gonna happen? I take CH, H, Cl, Cl. Okay? Central atom is the host. What it will try to do? It will try to accommodate for the property of everybody. What is the behavior of chlorine? भाई मेरे को electrons दे दो. I need electrons. So carbon उसके लिए क्या करेगा कि भाई वो इन orbitals का p character increase कर देगा. And अगर p character यहाँ पे increase हुआ है तो यहाँ पे s मुझे increase करना पड़ेगा. Otherwise the net hybridization would not be equal to sp3. See, the thing is, each bonds S and P character can modulate, but the average should be equal to sp3. So अगर मैंने यहाँ पे P increase किया तो यहाँ पे S character increase करना पड़ेगा. अब S character increase करेंगे तो ऑर्बिटल छोटे हो जाएंगे, and orbitals will lie close to each other, तो उनके बीच में repulsion ज़्यादा होगा. So if S character increases, bond angle also increases. अब चेक कर लीजिए, sp में बॉन्ड एंगल कितना होता है 180, s कैरेक्टर कितना है 50%. sp3 बॉन्ड एंगल इज 109 डिग्रीज. व्हाट इज द s कैरेक्टर 25%. तो s कैरेक्टर इंक्रीज किया, बॉन्ड एंगल इंक्रीज कर गया. सो इस रीजन में s कैरेक्टर ज्यादा है, इस रीजन में s कैरेक्टर सबसे कम है. सो ये जो एंगल रहेगा, दिस एंगल विच इज अल्फा, अल्फा शुड बी द हाईएस्ट. और सबसे कम कौन सा रहेगा जहां पे p कैरेक्टर सबसे ज्यादा है, विच इज गामा. सो गामा यहां रहना चाहिए एंड बीच में बीटा. ओके, सो आंसर क्या हो जाएगा? अल्फा इज, आई विल शो यू द ऑप्शंस. अल्फा इज लेस देन बीटा, लेस देन गामा. बीटा इज लेस देन अल्फा, विच इज लेस देन गामा. अल्फा इक्वल्स टू बीटा इक्वल्स टू गामा, विच इज द मेजर मिस्टेक most of the students are gonna do. The correct answer is D. Alpha is greater than beta, which is greater than gamma. Is this clear? Okay, fun to concept, exact application of जो पहले हमने पढ़ा है. Move on to the next question. Okay guys, so let's look at this problem. Which of the following statement is correct? The basic strength of hydrides of group 15 decreases down the group. So how do we analyze this? Ammonia, PH3, ASH3, SBH3 and BiH3 are the hydrides of group 15. Anybody would look at these atoms, nitrogen, phosphorus, arsenic, antimony, bismuth, and would say that the electronegativity of nitrogen is maximum, so tendency for it to donate electrons will be least, and which is like fairly correct because that is what you have read. Okay, but when we analyze the basic strength, we find out that the basic strength rather goes in this order. Okay, the reason for this is, if we analyze the bond angle of ammonia, it is 107, and phosphine it is somewhere about 93 degrees. So if we look at the bonds of nitrogen, hydrogen in ammonia, and we look at the bonds in phosphorus, they seem like almost orthogonal with respect to each other. Orthogonal मतलब 90 degrees पे हैं ये. If they are almost at 90 degrees, इसका मतलब ये है कि अगर हमने phosphorus का atomic configuration लिखा, so it will be 3s2 3p3. If bonds are almost 90 degrees, that means only p orbitals are utilized in bond formation. S orbital is not utilized in formation of bond. So that means the lone pair, which is these two electrons, are present in almost 100% S character orbital, and this is present in a sp3 hybridized orbital. In a sp3 hybridized orbital, the S character is 25%. So अब बताइए कहाँ से इलेक्ट्रॉन्स निकालना इजी होगा? This is 100% S orbital. This is 25%. So what does it mean? If it is closer to the nucleus, if the nucleus holds the electrons very tightly, then it is difficult to remove electrons from there. But if the s character decreases, the tendency for it to lose electrons will increase. That's what we have learned until now. So pH3 will become a weaker base as compared to NH3. How do we verify this? If you take pH3 in water, it will not form pH4+, but ammonia, if dropped in water, will easily form NH4+. ये बहुत ही important observation है. Okay, pH3 will not form pH4+. The basic strength will decrease. Another important reason is whenever hybridization takes place, the tendency for hybridization will be high if the energy released in bond formation compensates for whatever energy was required for hybridization. Hybridization is an endothermic process. Investment है वो, energy का investment है. Returns आपके ज़्यादा होंगे तो आपका investment थोड़ा ज़्यादा भी रहे तो दिक्कत नहीं है. आपने pH3 bond बनाने के लिए you need a substantial amount of energy for hybridization. That is the reason pH3 remains unhybridized. pH5 is not formed, but PCl5 is formed and PF3 is formed. If peripheral atoms are electronegative, hybridization can take place, but as we go down the group, the tendency for hybridization decreases. This is a very important rule known as Drago's rule. Drago's rule suggests that as we go down the group, the tendency for hybridization decreases, and this is also observed in H2O and H2S. H2S में bond angle about 92 degrees रहेगा and H2O bond angle is 104 degrees. So if ever it is being asked that between these two which is a better Lewis base, then your answer should always be H2O, not H2S, even though oxygen looks as to be more electronegative. The reason is the same. Lone pair is present in a pure s orbital in H2S, while it is present in a almost 25% s character orbital in case of H2O. Okay, so the first statement is correct. Clear? Let's move on to the next statement. The next statement is NN bond length is more than NN bond length in N2H4 is more than N2F4. This is very easy to analyze. ये हमने अभी काफी समय से कंसेप्ट को समझ रहे हैं. N F N F central atom, host, peripheral atoms, guests. So what does fluorine require? Give me all the electrons. So central atom will increase the p character over here. To compensate for whatever is lost in the s character in these bonds, it will increase the s character in this bond, in this region, in this bond. Net hybridization around nitrogen should be sp3. Net hybridization in this also is sp3, but this bond has more s character. So if s character increases, bond length decreases. Okay, bond length decreases, bond becomes stronger. So NN bond length in N2H4 is more than N2F4, which is correct. ये तो correct हो ही गया. BO bond length in BOH3 is less than that of BOH4 minus. This is very easy to analyze. This is BOH3. And this is BOH4 minus. Okay, now tell me something, in which case the central atom is having vacant orbital. This one, 6 electrons, एक vacant orbital है, so it will receive electrons from oxygen. If it receives electrons from oxygen, what will happen? I'll draw it over here. It will form BOH double bond O, OH H minus plus, nothing but resonance. Vacant orbital resonance. So remember, back bonding is lone pair vacant orbital resonance. Resonance के कारण bond strength, bond में partial double bond character आ जाता है, and the moment single bond acquires a partial double bond character, its bond length decreases and bond strength increases. So bond length यहाँ decrease कर जाएगी. इसके साथ और दो chemical structure बनेंगे आपके पास. So bond length will decrease So BO bond length in BOH3 is less than BOH4 minus, which is very, very true. Okay. The last statement is something which bothers students a lot. So let's try and understand it in a simple way. S double bond O double bond O double bond O. How many bonds need to be formed? 6 bonds. 6 bonds में 3 sigma है and 3 pi. 3 sigma bonds, that means sp2 hybridization, and 3 pi bonds need to be formed. How many unhybridized p orbitals are present over here? 1. And since sulfur is present in the third period, so it will use 2 d orbitals. Oxygen is present in second period, so it can only utilize p orbital. So if sulfur and oxygen needs to form pi bond, it will form a pi bond using p 3p of sulfur and 2p of oxygen. And if sulfur needs to form another 2 pi bonds, it will utilize 3d orbital. It will utilize, यहाँ पे तो 2 d orbitals थे. These are 2 d orbitals present, and these 2 d orbitals are 3d, which will overlap with 2p. Okay, so this 2 represents the number, not 2d. Okay, this is not the principal quantum number. So this there is a p orbital. There is a p orbital, and this is a 3p orbital which will overlap with 2p, and 3d overlap with 2p. How many unhybridized p orbitals are present? 1. Other 2 d orbitals would be used. So how many p pi 1? Total number of p pi d pi will be 2. 2 p pi, no, this should be 1. This should be 2. Let's take another example. Sulfur in H2SO4. Sulfur in H2SO4. Sulfur hybridization is sp3. No unhybridized p orbital is present. So these 2 pi bonds would be formed using d orbitals. So you will have no p pi overlap, and you will have d pi p pi overlap. D pi p pi. This p pi is p because oxygen will utilize its p orbital to form a pi bond with the d orbitals that sulfur is giving. Okay, it's very, very easy a concept. Okay, so our correct statements of these 3, so it will be 1, 2 and 3. Okay, let's move on to the next question. Which of the following set of molecules have the same shape but different hybridization? Okay, very easy question. Let's start writing for molecules. H2O, hybridization is sp3, shape is V-shaped. Okay, H2O V-shaped. Why? O H H, ये lone pair, यहाँ पे रहता है. SnCl2. How many electrons are there in the valence shell? 4 plus 2, 6. So hybridization should be sp2. Okay, so SnCl, and there should be a lone pair. Okay, 4 plus 2, 6. This should be your answer. Let's take XeO4. Xenon 1, 2. This is XeO4. Hybridization is sp3 tetrahedral. Why tetrahedral? All bonds are sigma bonds which are utilized for performing hybridization. Okay. Next, SF4. 6 plus 4, 10. 10 means sp3d hybridization. What we have to identify? Same shape but different hybridization. same shape but different hybridization. So hybridization is sp3, hybridization is sp3d. So SF4, I'll write it like this, F, there'll be a lone pair. Let's take XeO3, xenon, lone pair, double bond O, double bond O, double bond O. How am I doing this? 6 electrons, 7, 8. Hybridization is sp3, shape would be pyramidal. BRF3, ClF3, BRF3. Okay, they're the same thing. XeO3, BRF3. sp3d, T-shaped, T-shape का रहता है ये. BeCl2, linear, sp hybridized. एंड I3 माइनस, इसको कैलकुलेट करना थोड़ा डिफिकल्ट होता है, बट इसको इस तरह समझ सकते हैं कि I इज कंबाइनिंग विथ 1 iodine न्यूट्रल एंड 1 iodide. So 7 plus 1 plus 2. 1 iodine is combining with another iodine plus I minus. So this comes along with 2 electrons, this comes along with 1, this has 7 electrons in the valence shell. So this makes it 5 electron pair. All iodines will be placed in the axial position क्योंकि lone pair 3 हो जाएंगे, 2 peripheral atom रहेगा. So it will be sp3d, shape will be linear. So BeCl2 I3 minus, shape alike, hybridization different. So ये तो होना चाहिए. Okay, H2O SnCl2. What is this? What can be the shape? How to identify the shape? You ignore the lone pair और देखो कैसा दिख रहा है. ये V shaped है, ये भी V shaped रहेगा. So आंसर 1B हो जाएगा. So the correct answer should be B, 1 and 4. बाकी और केस में नहीं हो रहा है. Okay? Is this clear? So this is a very easy way of identifying कैसे अपने ये क्वेश्चन सॉल्व करना है. इस तरह क्वेश्चन बहुत बार दिए गए हैं and it's an easy concept. Which of the following overlap would result in the formation of bonding molecular orbital? Now what is the meaning of a bonding molecular orbital? Bonding molecular orbital is friendship, and anti-bonding molecular orbital is like dushmani, is like enmity. So bonding molecular orbital is favored and anti-bonding molecular orbital is not favored. So if I take the example of friendship and enmity, then bonding molecular orbital will have lower energy and anti-bonding molecular orbital will have higher energy. There is one another beautiful reason. If we look at 1s, if we look at 2s, if we look at 3s, the number of radial nodes in 1s we calculate is using n minus l minus 1. Number of radial nodes over here is 0. Number of radial nodes over here is 1. Number of radial nodes over here is 2. If we look at the energy of these three, what will be the order of energy of these atomic orbitals? 3s is more than 2s, which will be more than 1s. ये तो Aufbau principle भी आप जानते हैं. Why is the energy increasing? There is one another reason, that the number of nodes is increasing. So if nodes increase, energy also increases. Okay, so we can extrapolate this argument for bonding and anti-bonding. In bonding molecular orbital, number of nodes is less than anti-bonding molecular orbital. Okay, So remember guys that the anti-bonding molecular orbital has higher number of nodes, and that's the reason it is having higher energy, or presence of an electron in anti-bonding is not favored. Presence of an electron in bonding molecular orbital is favored. Okay, let's look at how to solve this question. Which of the following overlaps will result in the formation of bonding and anti-bonding? Now what we can see over here is shaded coming close to a unshaded part. So shaded and unshaded are of opposite phases. So we can put this plus and ये minus कर देते हैं, and ये minus हो गया, ये plus हो गया. Plus and minus are facing each other. This is known as linear overlap. Plus and minus are facing each other. That will be destructive interference, and this will form anti-bonding. Okay? Plus and plus are facing minus and minus are facing each other. They'll add up. This will be bonding. Wherever there is cancellation, plus and minus cancellation, anti-bonding. Minus and minus addition, bonding. Plus and plus addition, bonding. Okay, so you could be given plus or minus signs, or you could be or the lobes can be shaded. One another thing that I can tell you is, since they are overlapping along the axis, they are moving, approaching each other along the axis, this is the head-on overlap. So this will be known as a sigma star or sigma anti-bonding, and this will be known as a sigma bonding. Okay, depending on how they approach, you can identify whether it is sigma star or sigma bonding, pi star or pi bonding. Now what is happening over here? If they overlap, can we say over here that if they overlap, there would be equal overlap in the positive region and equal overlap in the negative region. This is plus, this is minus, और ये अगर minus ले लिया आपने, ये plus ले लिया. So minus plus cancellation, minus minus addition. So this will result in non-bonding. Equal positive and negative overlap will result in non-bonding. That is the reason. Suppose this is px and this is py. Px and py will not overlap. Px will overlap with Px, Py will overlap with Py. Okay, so Px and Py will not overlap laterally or like this fashion to form a bond. So they'll form a non-bonding orbital. Over here as well, इसको minus ले लेते हैं, इसको minus और इसको plus ले लेते हैं. What you can see is something like this will happen. Equal overlap in both directions. Say minus, plus, minus. Cancellation, addition. This will be non-bonding. Okay, cool. So this will be non-bonding. Fine. So remember this guys, if there is cancellation, that means anti-bonding is formed. If there is addition, bonding is formed. If equal amount of cancellation or addition takes place, it will be non-bonding orbital. Okay, so this along with this should solve your question. And please do remember this, ये काफी important है, काफी interesting है. Anti-bonding में nodes ज़्यादा होते हैं, bonding में nodes कम होते हैं. That is the reason anti-bonding becomes more energetic than bonding. Okay, or electrons presence in anti-bonding is less favored as compared to electrons present in bonding molecular orbital. Okay, fine. Let's move on to the next question. Which of the following is the correct relation between the stability of the following species? Now N2 N2 plus N2 minus, मैक्सिमम लोग इसमें गलती इसलिए करते हैं क्योंकि मॉलिक्यूलर ऑर्बिटल कॉन्फ़िगरेशन लिखना सभी को आता है. Most of them know how to write molecular orbital configuration, and the mistake that they do is analyzing the stability, comparing the stability with bond order. Bond order is half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. Okay, now if I try to write the MO configuration for N2, if I write the MO configuration for N2 I'll write it as sigma 1s2. How many electrons are there in N2? 14. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Okay, then comes pi 2p y2, pi 2p z2, sigma 2p x2. That's it. How do we write MO configuration? एक पर्टिकुलर ट्रेंड है, किताबों में दिया रहता है, उसको एक बार याद कर लीजिए. बोरॉन, कार्बन एंड नाइट्रोजन में pi 2py, pi 2pz come before sigma 2px. That's it. That is what you have to remember. Okay. Try not to remember any shortcuts for this because this is vital. So do a bit of practice. Do a bit of practice. So now I have to go to N2 minus. Now this looks like it is completely occupied. अब तो यहाँ पे कुछ रख नहीं सकते हैं. Atomic orbital theory में भी you can place 2 electrons in an atomic orbital. Similarly, in molecular orbital theory, you can place only 2 electrons in a molecular orbital. So you have to place an electron in an orbital which comes after this. इसके बाद जो आएगा उसमें आप रखोगे. इसके बाद क्या आता है? इसके बाद आता है pi star 2py, pi star 2pz and sigma star 2px. If I follow Aufbau principle, I'll have to place electrons in the lower energy one. So this part is same. This part is exactly the same, and this next part comes over here. So I have to place an electron over here. Now I calculate the total bond order. Number of electrons becomes 15. If I calculate bond order, कितना होगा? Half. Number of electrons in bonding, 2 plus 2 plus 2 plus 2 plus 6, 10 minus 4, that is 3. Let's calculate over here. Half 10 minus 4 is 3. Let's calculate in this case. Half 10 minus 7 10 minus 5, that gives me 2.5. Okay, I count the total number of anti-bonding, it gives me 2.5. If I try to write N2 plus, I will remove an electron from here, and that will give me only 9 electrons in bonding molecular orbital. 9 minus 4, that also comes as to be 2.5. For 13 electrons comes as to be 2.5. Now you must have read this rule that bond order increases, stability increases, bond length decreases. Okay, but what if the bond orders are equal? Okay, so remember this. If bond orders are equal, the one with lesser number of electrons in anti-bonding will be more stable. इसको याद रखिए. Lesser number of electrons in anti-bonding will be more stable. अगर हम इन सबको देखें, then in N2 the number of electrons in anti-bonding, bond order is highest. So I obviously know that N2 would be most stable. Bond order is highest. If bond orders are equal, number of anti-bonding electrons in N2 minus will be more than the number of electrons in the anti-bonding molecular orbital N2 plus. So the order should be N2 प्लस N2 माइनस, बिकॉज इसमें एंटी बॉन्डिंग में कितने इलेक्ट्रॉन्स रहते हैं? एंटी बॉन्डिंग विल हैव 5 इलेक्ट्रॉन्स. In this case, anti-bonding will have 4 electrons. Okay, so the correct answer should be, most of the students will write C, but the correct answer is, yep, B. Okay, the correct answer is B. Fine. Let's go on to the next question. In which of the following cases the value of magnetic moment, in which of the following does the value of magnetic moment change? It's very easy to calculate. Carbon monoxide दिया है आपको, you have been given carbon monoxide. So the moment carbon monoxide is given, carbon monoxide is 14 electron system, so carbon monoxide को आप नाइट्रोजन जैसा ही evaluate कर लीजिए. आपने N2 को, N2 का all electrons are paired, changes to N2 plus. Okay, you can keep this as your homework. Okay, इसको आप homework जैसा ले लीजिए. It's easy. N2 को N2 जैसा मान लीजिए, ये N2 plus में change किया, which is similar to CO plus. N2 plus changes to N2 minus. You know this. We have just solved this. O2 changes to O2 plus. Try to write the MO configuration. H2 plus changes to H2 minus. Try to write the MO configuration. Once you solve this question, you will get certain results. The number of unpaired electrons will give you the magnetic moment. So number of unpaired electrons utilized in obtaining magnetic moment. So magnetic moment कैसे निकालते हैं? रूट ओवर n into n plus 2 bm, where n is the number of unpaired electrons. Okay, it's a very simple question. Try to solve this. Let me know the answers in the comment section. If you are not able to solve, or whatever your answers you are getting, just let me know in the comment section. I'll help you out in this case as well. But it's an exact extension of whatever we have learned until now. So I'm not solving this question. Try to work on this. Okay, let's look at the next one. Okay, which of the following statements is correct? And probably this will be the last question for the series. Which are the following statements is or are correct? Ion dipole interaction is responsible for hydration of Na plus. Now these questions are from the weak intermolecular forces. Weak intermolecular forces बहुत तरह के होते हैं. Ion dipole या फिर ion dipole is not recognized as the weak intermolecular force, but hydrogen bonding, dipole, instantaneous dipole, dispersion forces, van der Waals forces. लेकिन हम कैसे उनको समझे? Ion dipole interaction is responsible for Na plus. So this is Na plus और ये H2O. इसमें एक परमानेंट डाइपोल रहता है. So on and so forth. I can form substantial this will undergo hydration, and this attraction is between ion and a dipole. So ion dipole interaction is responsible for hydration of Na plus, which is correct. Hydrogen bonding is dipole interaction. Let's say HF, delta minus, delta plus, delta minus. What kind of interaction is this? This is a dipole, this is a dipole, so this is dipole. This is also correct. Solubility of noble gases in water can be explained by dipole-induced dipole interaction. See, if you take xenon and try to put this thing in water, it will dissolve. How? Xenon is a very large atom. H2O molecules are in the form of a dipole. So, at a low temperature, collision will take place, and that will cause a small degree of polarization of the cloud, distortion of the cloud, and that distortion will change the shape of this to something like this. Okay, so positive, positive, negative, negative, negative. Okay, it will change and इनके बीच में एक attractive interaction होगा, which is a dipole inducing a dipole. Dipole के कारण dipole बन रहा है. So dipole induced dipole explains the solubility of noble gases. Formation of liquid helium can be explained by London forces. London forces are nothing but dispersion forces, or London forces can also be written as instantaneous dipole interaction. They can be called instantaneous dipole interaction. In a given instant, this dipole interaction takes place. So what happens is this is helium, another helium unit. They will collide with each other, and for a very small fraction of time, they will cause a small degree of polarization. Polarization का मतलब development of charge. Okay, and इनके बीच में attraction होगा. This is known as instantaneous dipole interaction. So fourth is correct, third is correct, second is correct, first is correct. So answer should be D. Okay, fine. So what were the key areas? The key areas are VSEPR theory, hybridization, back bonding, molecular orbital theory, and weak intermolecular forces. इनके ऊपर आपको ज़्यादा फोकस करना है. If you are not very comfortable with advanced rule, थोड़ा सा उसके बारे में पढ़ लीजिए, रूल्स याद रख लो, थोड़ा सा मेटेलिक बॉन्डिंग के बारे में पढ़ लो, बट इनके ऊपर आपको ज़्यादा फोकस रखना है. एंड this lecture was exclusively designed for making your concepts a bit more refined in these very areas. Try to remember that concept where S and P mixing हमने बताया था, and to explain how S character increases, P character increases, basicity, extent of hybridization. Try to remember those things because they are more frequently utilized in asking questions. Okay, so you know the drill. If you have liked the video, please press like, please share the video with your friends so that they can be benefited as well, and subscribe so that you are up to date with all the academic content that comes from Vedantu, which is the best in the country. So this drill, keep following this, and we'll meet the next time with a very interesting topic known as coordination compounds. Thank you, and I'll be signing off. And in a while, I guess your mathematics class will start. Okay, thank you. Thanks a lot.